Because this rate is what? Positive, right? It's like saying that the function is increasing because the derivative is positive. The function decreases when the derivative is negative, right? The derivative is a rate. This is a rate also, but it's an average rate. You understand? Yes? What if we had the bacteria and it started the other way? And the bacteria was high, right, in our system, and then they give us medicine, and what happens to the bacteria? It declines, right? So the bacteria is decreasing until it goes away and I'm healthy again, right? That specific bacteria. So let's say that happened, and this rate was negative 95/11. Then we would say what? On average, the population of the bacteria is what? Decreasing at a rate of? Do I have to say negative here again? No, why not? Because I already said it was decreasing. So here I just put the rate that it would have. I wouldn't say negative again. Okay? Do we understand?
Yes.
Awesome. Let's try another one, okay? Now this one says you could use your calculator. Let's see. Traffic flow F of t is defined as the rate at which cars pass through an intersection. That makes sense, right? Traffic flow? Yeah. And it says it's measured in what? Cars per minute. So that means that F of t is already in what? Cars per minute. That's a what?
Rate of change.
That's a rate of change. So that means F of t is a function that's talking about a rate. Do you understand? And it said t is in what? Minutes. The traffic flow at an intersection is modeled by this function. So this is already some rate for 0 to 30 minutes. What is an average rate of change of the traffic flow over the time interval 10 to 15? Okay, so again, we're looking for the what? Average rate of change. So what do I need for that? 2 points. Do I have the 2 points?
Yeah.
10 something and 15 something. So I only have the x parts of the point.
So you find u.
How do I find the y's?
FB minus FA.
Very good. So I have to do f of b minus f of a. Okay, so basically we're trying to find f of 10, right? And we need to find f of 15. So you need to plug those in, use your calculator, Martin, and figure out the values. 82 plus 4 sine of 10 over 2. 82 plus 4 sine of 15 over 2.
So you get like 78.164.
164, okay, and this one?
85.752.
85.752? Beautiful. Okay, so do I have my stuff now that I can use? Yes, okay, what's gonna go on the top? We're looking for AROC, average rate of change.
The 85.
So 85.752 minus 78.164 over 15 minus 10. So what does that give us approximately as a decimal?
Yeah.
7.593.
I think that's the part on the top, divided by 5. 1.518.
9. You round
You round.
That's after that.
Is this after rounding or before rounding? After?
No. Because the actual number is 1.5176.
Doesn't matter.
Good? Yes? Okay. So now what would be the units of measurement for this?
Traffic per minute.
Cars per minute?
Yeah.
Are you sure?
No, this is just time.
What did f of t stand for? What did it tell you that the original function was? That one was already cars per minute. So it's like saying here, cars per minute. And then this is also a number that's cars per minute. And then in the bottom, these numbers represent what? Minutes. So what should my units be? Cars per minute
Squared.
per minute, right? Which is like cars per minute squared. Very good. So this should actually be 1.518 cars per minute squared. Ooh. Physics. You've done this in physics before?
No.
So what would that tell us? What is that describing? On average, what? What's changing? You need to be able to tell me this because you're going to have to do this by yourself.
The traffic flow.
The traffic flow,
That's all I have.
on average, the traffic flow you want me to keep writing?
Increasing.
The traffic flow is increasing?
It's positive.
Okay, so the rate is positive, so it's increasing at a
At a rate
rate of
of 1.518 cars per minute squared.
1.518 cars per minute squared. Is that all the time? No, it's only during a specific time, right?
10 to
10 to
10.
15 minutes.
From t equals 10 minutes to t equals 15 minutes. Beautiful, okay? We need to be able to not only find the answer, but understand the answer and know what it means in context of the problem. Good? All right, so we go with average rate of change? Not really?
It's okay.
It's okay? It's super easy, basic slope?
Yeah.
Yeah.
All right, so now let's crank it up a notch and let's do some calculus.
Oh,
So now we're talking about what?
IROC.
IROC, which is the other type of rate of change. This one's the instantaneous rate of change. It's the slope of a what?
Tangent line.
Tangent line. So all I need to know is how to find the what? The
Derivative.
derivative, okay? But not only find the derivative, but evaluate the derivative at that number, right? And then understand what it's telling me. So let's look at this first problem. Okay, Jared, will you read it for us?
If the function f given by f plus x equals negative x cubed plus 3 over 5x squared minus 4x is a measure of the miles traveled with x measured in hours. Find the instantaneous rate of change when x equals 2. Indicate the units of measurement.
Okay, so what does this equation tell us? If I use this equation, what would it give us? Well, if I plugged in an x, what would it tell us? So the measure of the miles traveled, right? Okay, not per hour. This is just going to give me the number of miles traveled, right? Not per hour, it's not a rate. It just spits out how many miles you traveled. So if I plug in 5, it tells me how many miles I traveled in 5 hours. If I plug in 10, it tells me how many miles I traveled in 10 hours. Do we understand? Okay, this one's a little bit different than the one we just did. The other one was a rate, right? And you were plugging stuff into that rate. So that's why it became like cars per minute per minute. Cool? Alright, so let's check this guy out. So in order to find the instantaneous rate of change, whenever I see that word, I'm automatically thinking slope of the tangent line. Boom, derivative, plug in the value. So let's go. What is the derivative of this guy?
Negative 3x squared.
Let me rewrite it first before we take off, or you want to do it already?
Okay, fine, go ahead.
I can rewrite it on top. I'll rewrite it up here. So this is negative x to the third plus what?
3.
15.
So I'm going to do 3 over 5 like that, and then I'm going to put x to the what? not negative third,
Second.
negative 2.
Oh, you're just sending the X up?
I'm just sending the x, that's the only part that has that I wanna move up. I'm leaving the 3/5 there as a constant. Are we okay?
I'll see.
You'll see? If you wanna send the 5 up, then you have to say 5 to the negative 1. Okay, and then that'll be a problem. Alright, so let's find the derivative since you guys already started. Negative 3x squared. Okay, and then minus
Oh, do you just send the?
6.
6 over 5 x to the negative 3 minus what? 4. And we could rewrite this as negative 3x squared minus 6 over 5x to the third minus 4. And can I leave it like that? Yeah, that's good enough, right? So now I can just evaluate it. So what would f prime at 2 be? Negative 3 times 2 squared. Use your calculator. What's that guy gonna give us? But I have done all this on the calculator from the beginning.
Yeah.
Yeah, right? I could have just gone to menu, calculus, right? Derivative at a point. And at what point do we want it at? 2. And then ask it to find the derivative of this guy. So you do it the way we did it, and I'll do it like this so we get the same answer. What do you guys get? Negative what? No, I'm doing it a different way. You found the derivative and you're plugging it into the derivative. I didn't find the derivative. I'm gonna let the calculator find it for me and plug in the
I
number.
got a nasty fraction.
You got a nasty fraction?
Yeah, negative 320.
Negative 323 over 20?
Yeah.
Cool, I got the same thing, right?
Yeah, but you.
But I had to do a lot less work because I used the calculator to do it for me, right? Because that's one of the things that the calculator can do. Okay? But what if this problem wasn't on the calculator section? Which it probably wouldn't, because that's an easy derivative to get. Okay, so you do need to know how to do it by hand. So this should be negative 323 over 20. But if this problem, Martin, was on the calculator portion of the test, I wouldn't sit there doing it by hand because I can use my calculator to get the value, right?
You go menu.
So menu,
4-1.
4, 1.
And you plug in the X value that you're looking for, and you plug in the.
Awesome. So what would that be as a decimal? Control, just press Control, Enter, guys, and it'll convert it to a decimal. So negative 16.15.
So would we want it in decimal form, or would it be okay in fraction?
Either way, they're equivalent.
Well, it depends where it is, because if it's on the multiple choice one, like it's gonna be.
Right, if it's multiple choice, you gotta make it match. If it's on the free response, it doesn't matter. I would just stop there and not risk getting something wrong. Okay? So, indicate the units of measurement. So what would the units be?
Miles per.
Miles
Miles per hour?
per hour?
I mean, it says miles, yeah.
Yeah?
Sure.
It's a rate, right?
Yeah.
And what was the function talking about?
Miles.
Miles, right? So if we think on the graph, right? We're gonna have miles up here, right? And we're gonna have hours down here. So if I figure out the slope of a curve on that graph, it will be miles per hour. So we're good. Okay, so now what does that tell me? Can I interpret the meaning of this derivative?
On average.
Is this average?
No.
No.
Well, actually, just 2.
Good, that's a good start. So what does this mean? When x equals 2 miles,
Then you are going at negative average.
the object, whatever they're talking about, right? They didn't tell us if it was a car. The object
Travels.
Okay, is traveling.
Negative 16.5
What does that mean, negative 16.15 miles per hour?
Slowing down at that rate?
It's slowing down?
I mean, if it's negative. Or,
What do we call this rate of change? The distance over time, that's called the what?
acceleration, is decelerating?
No,
Velocity.
This is called the velocity, right?
Yes.
So velocity, remember, is a vector, right?
Yeah.
And vectors have two things. What? Magnitude and direction,
Yes.
right? So the magnitude here is 16.15, and the negative is telling us the direction. So that's basically telling us that this object is what? Either falling or traveling what? Backwards to the,
Starting point. Beginning, I don't know.
I don't
in
know.
calculus, we have rectilinear motion, so that's either to the right or to the left. So in this case, since it's negative, it would be traveling to the left. Okay? If it were an object, talking about an object falling, right, or an object thrown in the air, then this would be saying that the object is what? Going down, is falling, okay? So here we could say when x equals 2 miles, the object is traveling to the